All right, so 7.2 is a quadratic formula. That starts on page 311. Now remember, your homework is page 314, 7.2, numbers 8 through 18 even in the written exercises. All right, so they start off this section by explaining how we get the quadratic formula. So you start with a polynomial in standard form, right? Standard form polynomial, descending order set equal to 0. This is what it looks like. You can actually use this to get your quadratic formula. So the way they do that is by completing the square. All right, so the way they started out is, remember, step 1 is to make sure it's in standard form, which this is. And then the next step is to actually get rid of the coefficient on the first term, which is a. So if we divide both sides by a, we'll get rid of it on the first term. So it'll cancel out on the first term. The next term will be b over a times x. The constant is c over a. And this is set equal to 0 because 0 divided by anything is 0. So now that we have it where the coefficient is gone, we can go ahead and start completing the square. So we're going to subtract CA from both sides so that we can move our constant to the right side. It's always step 2. So we leave a space to complete the square. And remember, we're going to take b over a and we're going to divide it by 2 and square it. So let me do that out to the side as a little side note so I can show you that this does in fact equal what they have in your book. That was probably not big enough. But here we'll have b over a, and we're dividing it by 2, which is the same thing as taking, if we're going to multiply it, we're going to multiply by the reciprocal. So we have b over 2a, and then the whole thing is squared. So we'll have b over 2a, and the whole thing is squared. And that's what they have in your book. All right, so we're going to do it to this side, because what you do to the one side, you do to the other. Property of equality. And that's completing the square right there. So now we know that this is a perfect square trinomial. We can break it down to factored form. And then we have this crazy thing that we would want to put together. So the way we would do that is to give them a common denominator. So let's go ahead and square that term. So we'll have negative c over a plus b squared over 4a squared. And then we want to put these together. So let me rewrite this side of the equation. Now the common denominator would be 4a squared. So this is going to need to be multiplied by 4 times a. So 4a over 4a will give us 4a squared in the denominator. So we have negative 4ac all over 4a squared plus b squared over 4a squared. Now that we have a common denominator, we can actually put this together. Let's use commutative property and flip it so that we'll have the negative term as a minus. So b squared minus 4ac all over 4a squared, right? And then over here we rewrite this like so. And now we can actually extract the square root of this crazy fractional expression. And we'll have x plus b over 2a is equal to the square root of b squared. So the square root of a fraction, we can break it into the square root of the numerator and the square root of the denominator. So let's do that. We'll have the square root of b squared minus 4ac all over the square root of 4a squared is going to be what? 2a, right? So take square root of the coefficient and the square root of a squared. And then the last step is to get x by itself. So we're going to subtract b over 2a from both sides. Put the radical after, always. Oh, I don't know why I always forget that. Plus or minus.